All right, well, it looks like our last few people are logging on right now, so we'll get started. Today's webinar is on commercial humidification. So we're going to go into some of the different types of products that we use and different sizing that we use for commercial humidification. It's a lot different than your standard, fan-powered bypass humidifier that we use in the residential marketplace. So there's a lot of different things that are incorporated in that. We're going to look at the basics. We'll take you back to humidification basics, different product types, different applications, a lot of different applications for commercial humidification, a lot more than you may think. So we'll look at some of those as well, and we'll look at some of the selection and sizing that's available. So if we go back, why do we humidify? We humidify obviously for people, right? We know this from a residential aspect. Comfort for people, we need a specific humidity level, but also in hospitals, research labs, we're using humidity to heat hot yoga studios and maintain those temperatures. We've got theaters, shopping centers. So a lot of different comfort applications for humidity and humidification. We also humidify for products, specifically for manufacturing, industrial products, composites, things like that, and also for preservation, which makes sense if you think about museums and antique storage, not letting too low or too high humidity degrade some of those products and some of those things that we're trying to preserve for generations and generations. So there's a lot of different reasons that we want to humidify. And how does it actually translate to ourselves? How does humidity feel? We can kind of all relate to some of those. In the winter, dry air makes us feel colder, right? Because the air around us is wicking moisture from our body, making us feel cold. And the same thing is actually happening in the summer, but the air is so humid that it can't wick that air off, and we actually feel warmer. So we know that we can sense humidity, and it makes a big impact on productivity and how people relate and feel comfortable in their environments and their work environments as well. Dry air not only affects people, but it affects things. So physically, on people, we can get dry skin, dry eyes. We can have irritated lungs. It can affect those people with asthma. And also on items, you can change the size, quality, consistency, and strength of many different products. I mean, we all know what the sun does to, our backdoor decks. Well, that same thing can happen within spaces to our hardwood floors and some other things if that humidity level is not kept consistent. So just a few of the reasons to kind of propel why commercial humidification is growing. Just to give you a thermodynamic background here, just look at this example here. If we take 1 cubic meter of outside air at 32 degrees, so if we're outside 32 degrees, the relative humidity of that air is about 75%. If we take that same cubic meter of air and we heat it to 68 degrees, which, by the way, is the average indoor temperature, that humidity decreases to 20% in that same cubic meter of air. So we've gone from 75% humidity to 20% humidity in the same amount of air just by changing the temperature. And 20% relative humidity is way too low for people and products. If you look here, relative humidity is actually a direct correlation between temperature. So the more air is heated, the lower the relative humidity. So if you can see the yellow circles, that's actually the air temperature increasing. But you see that same molecule of water vapor in each one, the relative humidity just decreases. So this is why we need to humidify spaces for the people, the products, and the preservations of different things. So that kind of spearheads us into why we want to do this. It makes mathematical sense. But there's a lot of other reasons why that ideal humidity range is a healthy thing for our environment and for the people as well. Now, this slide you may have seen before, but it's a really popular slide, and it makes a lot of sense because if you get too dry of air, you see a lot of those dry nasal passages, allergy stimulations, you see wood drying out, more bacteria. There's also a lot of viruses that can actually promote growth in dry areas. And the same thing we see in the adverse side with very humid spaces. You can see the molds and the, some of the dust mites and some of, furniture and wood itself also is affected from extremely humid climates. So we want to keep in that ideal range of 40 to 60% year-round. Obviously, that range can change depending on an industrial process or, a manufacturing process. But for most applications, 40 to 60% is what we're shooting for. Now, there's a couple of ways in the commercial industry that we use, not just commercial, I should say commercial and residential, that we use to humidify a space. One way is the generation or utilization of actual steam. The second way is using evaporative atomization of water. Well, I'll go through what each one of those mean. If you break those down, use of steam and the atomization of water actually breaks down thermodynamically into these two categories. One is isothermic humidification. The other is adiabatic humidification. So these are big words that you probably haven't seen since your, high school science class. But just to remind you, isothermic humidification is the introduction of water vapor into the air, and it's usually done by boiling water, and that vapor goes directly into the space. Now, it takes energy to boil that water into the vapor into the air, right? Adiabatic humidification, on the other hand, is the direct evaporation of water into the air. So in this side, we're actually atomizing water into very small particles and introducing it into the environment. So instead of bringing the water to a vapor state and then releasing it into the atmosphere or into the space, adiabatic humidification is actually releasing the water into space and letting the energy evaporate it. There's some different advantages to each one of these different types of systems. Isothermic humidification is associated with steam, and that temperature prohibits the growth of certain molds and bacteria. So that high temperature is very antimicrobial. On the other hand, adiabatic humidification is more cost-effective generally to operate because it's not relying on a source to get the water to evaporate. We're not boiling the water. We're actually just releasing that atomized water into the atmosphere and letting the atmosphere evaporate the system. So that energy is coming from the atmosphere. We're not having to boil it to get it into a vaporous state. So therefore, it's actually more cost-effective to operate. So those are just two differentiating factors between the two systems. But what I'm going to do is go through isothermic systems and adiabatic systems, kind of how they're divided up in the commercial multipliers. To give you a little more information into these systems, isothermic, we jump back into our psychrometric chart, right? Isothermic, if we look at from A to B, we're actually keeping the temperature constant, right? So we are actually increasing humidity in the space by introducing a water vapor directly into the space, but we're not changing the actual temperature. We're not changing the dry bulb. We're just affecting the latent load here. On the other hand, right, the adiabatic humidification, we're actually introducing atomized water particles into the air. So not only is it changing the relative humidity of the space, but it's actually also affecting the dry bulb temperature. So we're affecting temperature and humidity, whereas isothermal is just affecting the absence of the load. I'm sorry, it's just affecting the absence of the load. I said that backwards. My apologies. So let's look at the types of isothermal steam humidifiers. There's a couple different types. We've got electrode, we've got element, gas-fired systems, and direct steam systems. These are all isothermic humidifiers, meaning that they are just increasing the humidity or the relative humidity in the space, or adjusting the relative humidity, I should say. They're not affecting the actual temperature in the space. So let's go through each one of these different types because they're all a different technology as well. We start with electrode. An electrode humidifier basically uses a canister or a cylinder. Within this plastic cylinder, there's metal electrodes. And we immerse those metal electrodes into water. And what happens is we apply a charge to the electrode, and that charge goes out and makes an electrical connection with the minerals in the water. And so by doing this, the electrical charge between the minerals in the water and that electrode plate causes the water to boil. Makes sense, right? You can see a picture of an electrode humidifier here on the left. You can see that plastic canister we talked about. That electric current that is passed to the electrode is measured by a transformer, and this is also connected via software to the ratio of the water and the amount of steam that's produced. We can control that very well, and it has great accuracy. The one good thing to know about electrode humidifiers is they are recommended for use on regular tap water only. Now, if you look at what I said, the electrode plate makes a connection, electrical connection with the particles in the water. So there has to be some particles in the water. There has to be minerals in the water for it to excite and then boil. So you can't use water, osmosified water. You can't use deionized water or softened water, because what happens when you do that? Your deionized water, you're removing all those ions. You're removing all those particles and minerals from the water, so the electrode has nothing to interact with. So electrode system can only be used with regular tap water. The cylinders, the electrode cylinders themselves, usually are changed out every year, every 2,500 hours, I'm sorry, because those electrodes get some buildup on them, and every year you just change them out and the system operates continuously. And like I said, when you're using regular tap water, that does not include well water or water high in calcium or sulfate. So that kind of limits the use for electrode systems to just the regular tap water only. That well water will degrade the cylinder a little bit faster to affect the lifespan of that cylinder. The next type of isothermal humidifier we have is an electric element. The electric element humidifier is actually just like it sounds. It's an electric element that's immersed in water, and amperage is applied to the element, and thereby heating up the surrounding water and causing it to boil. So the difference between the electric element and the electrode is that it's not interacting with other particles in the water. This electric element itself is just heating up and then causing the water to boil. The difference is that now this elemental system can be used as tap water or deionized water because you don't technically need those minerals or particles to interact with. You still want to be concerned with your water quality, but it can be used for other deionized applications. It has really great accuracy, which makes it a really good product for demanding applications where you need a specific amount of humidity. And you'll find that consistent with a lot of the humidification products for commercial applications, but we'll talk about that a little bit more. Another one of the systems is the gas-fired system. So this is very similar to a traditional boiler for hot water on a much smaller scale. We have a burner heat exchanger system that boils the water. It's a 92-95% efficient burner, and it'll heat the water, it'll boil, and then it'll continue into the same system, steam distribution system. So 100% steam is actually produced and then delivered to the distribution outlets and distribution tubes. That's definitely not a new technology to us. The nice thing about a gas-fired system compared to the element or electrode is that it has a very wide operating range. It has a large capacity, and obviously right now lower gas prices can make it more attractive versus an electric system. We can use this for DI and softened water as well, so it's good for a large range of applications. The fully modulating gas valve allows it to obviously modulate and adjust to those precision relative humidity applications in different spaces as well. Direct steam is the fourth type of system that we use for isothermal humidification. Direct steam is exactly as it sounds. It's utilizing pressurized steam from a centralized system, and it's distributed into obviously ductwork or air handlers through these distribution tubes. So if you have a process or application or building that is currently using steam for some other source, whether it be heating or a process or a byproduct of manufacturing, you can use that steam to also humidify through these distribution tube systems. So the nice thing about the direct steam system is there's not a lot of moving parts. We're basically incorporating the distribution tube, so it extends the life cycle of this type of system. There's also high capacities available with these direct steam systems, and also the absorption distance, because the higher pressure of the system, the absorption distance from the distribution tube into complete vaporization of that water is relatively small. Carel also has a short absorption manifold system where we can get a full evaporation of water in 6 to 8 inches. Obviously, that evaporation distance is going to depend on the capacity of the humidifier itself, but as small as 6 inches, we can get full evaporation of that water. So these systems can be applied into air handler plenums. They can be applied directly into ductwork. And they can put into a lot of spaces where you have, a short distance before an elbow return in the ductwork itself, and you don't have to worry about condensation in the ductwork. So just to summarize some of the isothermal systems that we have, we've got the electrode, the element, gas-fired, and direct steam. And if you look on the right, you can see the different ranges of capacity. We rate them by pounds per hour. So the electrode and the element can handle very small loads up to about 200, 100 pounds per hour, and they can modulate fully within each one of those ranges. As you can see, the gas-fired and the direct steam systems have a larger capacity range, direct steam being the largest. The other type of system that we mentioned was the adiabatic system. Adiabatic systems, just to refresh, is where we finally atomize water, and we do this so we can expand the heat exchange surface so it evaporates directly into the air. Now, we need energy to get that spontaneous evaporation. So as that water shoots out of that high-pressure nozzle, we have a lot of that surface, and it interacts with the energy around it and absorbs energy or heat to change state, right, to go from a liquid to a vaporous state. So that energy that it absorbs actually cools the surrounding air. So we're all familiar with this, the theory of, swamp coolers or misters and things like that. So this is definitely an evaporative type cooling situation. But these systems can do both. They can actually cool air and they can also humidify air. So there's different applications for adiabatic systems than isothermal systems. So when you want to get that extra benefit of cooling a space, you can utilize an adiabatic system. Adiabatic systems can atomize water directly into the space. You see the small humid disk to the left there. We can actually put it much like a humidifier that you would use in a residential home. We can use these on a larger capacity scale, flow that humidity directly into the space. Or we can use the pressurized air and water, and we can use the nozzles in distribution tubes in air handlers or ductwork. These adiabatic systems can generally use, they want demineralized water. We can use tap water and things like that, but anything that can demineralize or distill will obviously extend the life of those nozzles and make it easier for maintenance on the individual nozzles and cleaning for the tube. These systems also have a larger capacity range, up to 2,000 pounds per hour, so similar to the direct fired and the direct fired steam systems. Adiabatic systems usually are utilized on larger commercial products where you have a centralized pumping station. This pumping station will provide high pressure water to these different nozzles that are located throughout the building, whether it's in ductwork or air handler. But these pumping stations are going to deliver water to each individual nozzle set. If you look at those pumping stations, they include variable frequency drives, DCM motors, full pressure switches, and high pressure pumps. There's not a ton of components that are involved here. We're just actually pressurizing the water and sending it out to different air distribution tubes. The panels themselves, or the distribution tubes, have multiple tiny nozzles. Depending on the size, there could be, anywhere from 10 to 25 to 100 nozzles on these vacuum systems, putting out anywhere from 6 to 8.8 tons per hour in each one of those nozzles. So they have an automatic washing cycle, and they have drainage when they're not in use to prevent any buildup of antimicrobials and things like that. They do have self-cleaning procedures involved with these tubes, but they do require an annual maintenance. Some of the single zone systems that you see are some of the zone controllers that can also be used, like this NC that you see here has, just to see inside the box, you've got the direct air line where pressurized air would come in, and then you have your water line. You would supply both the air line and the water line to these distribution tubes where it's combined at that nozzle. But not a lot of components, as you can see, pressure regulators, solenoid valves, and a pressure gauge. So not a ton of components that are involved, but the life cycle of these systems generally outlast the individual tubes themselves. Now, I mentioned before that we can combine multiple vacuum systems onto a single pumping station to do a multi-zone system. So if you do have a large commercial application, multiple spaces, we can use a centralized pump station and use individualized zone controllers to regulate the humidity to each one of those panels, each one of those vacuum systems in different air handlers or ductworks or locations. So generally, we typically do up to 6 zones, but we can, obviously modify and change the capacity of the system. As we mentioned before with the adiabatic system, I mentioned that they can both cool the air and they can also humidify the air. And the reason they can do that is because of evaporative cooling. So one of the other terms that you want to be familiar with when you're discussing commercial humidification is indirect and direct evaporative cooling. You also see these terms used with cooling towers associated with hydronic heating and cooling systems. But indirect and direct evaporative cooling for humidification also comes into play, where indirect evaporative cooling cools the air without adding moisture to the air. So we can actually use the atomized water to cool the air and not increase humidity, whereas direct evaporative cooling actually adds moisture to the air and then also cools the temperature. So there's 2 different ways of doing evaporative cooling in an adiabatic system. So when I said before, adiabatic not only affects temperature but also humidity, it can be done without actually affecting the temperature as well. So you can do direct or indirect cooling with an adiabatic system. Just to give you an example of how we can do an indirect cooling system with an adiabatic humidifier, we look at the layout. This could be an air handler layout or a ductwork layout. As you can see, you can do some pre-summer cooling all off the same pumping station for humidification system. You've got a racking system here that is pre-cooling exhaust air from the system, return air from your building combined with exhaust air, return air from your building being pre-cooled and then reintroduced as return air into the system. And then we can also humidify the space with a separate rack during the winter. So there's a couple of different applications. If you want to add a second zone, you can also humidify the air during the winter, as we pointed out. So that's another application. You can use that same pumping station to not only cool but also humidify the space, depending on the season and the requirement of the process. We jump right into types of sizing softwares and sizing for humidification systems. Let me make sure. We've got our expert panelists as well. You can also with us. So I want to make sure he's on board and he can throw in any comments. Sizing humidification systems commercially keeps me a little more cumbersome. But now that we see a lot of the manufacturers offer their own software, makes it very easy to size humidification systems. Traditionally, you can use types of methods, power, mechanical ventilation, or an economizer type of ventilation to calculate how much air is coming in at what humidity and what your mixed air conditions will be. But typically now all those manufacturers combine those into a single software program, as you can see below on the screen. Very easy to use. To give you one quick example, this is good to know as well. Important information when you go to size with humidifiers. I apologize. We're going to size and select the humidification system and ask the customer. You want to ask them about the building dimension and the space, obviously. Kind of same as when you're doing a load calculation for an HVAC system. So we want space dimensions, if nothing else. And also you're entering air temperatures and relative humidity conditions. So we can assume, Chicago design temperatures outside, but we also want to know what your design temperature for the indoor space is. So we want to know building dimensions and what your design relative humidity for that space is going to be. Those are the two minimum things that we need. It's also handy to have how many air changes per hour are utilized with that building if you have no other information on the HVAC system. If you do have information on the makeup air unit or the air handling system, you want to know the airflow of that system, so the CFM of the mechanical system or the economizer itself bringing in outside air. Obviously, as we talked about, the different humidifiers use different types of water. So if you know what type of water is going to be utilized, that'll help narrow down which humidification system is best for your application. Voltage, distribution systems also, whether it's going to be distributed directly into a ductwork or an air handler or into the space itself. Controls and integration capabilities. Each one of these systems has different capabilities as far as controlling precise control and also integration into building automation systems. So there's a lot of different things. There's a lot more questions to answer in a commercial sizing system, but these softwares do a really great job of walking you through that process. So let's look at one of those examples just so we can see what that's like. If we look to calculate the humidification load for, let's say, 120 by 80-foot building with 12-foot ceilings, we want a desired 70-degree temperature inside, 70-degree set point with a 50% relative humidity. Under air conditions, we'll just say during the winter, are 10 degrees with a 45% relative humidity, and they have 1 air change per hour. So just using that basic information of building dimensions and what our design relative humidity is, we can input that into the softwares online. So here's our outside design temperatures, and here's our space design temperatures. 70 degrees with a 50% relative humidity. Got a 120-foot building by 80 feet with 12-foot ceilings. Average air infiltration, synonymous with 1 air change per hour. And if we calculate that load, it comes up with 65 pounds per hour for that space. Simple as that. And the nice thing is that even if you don't know exactly what your design temperatures are going to be, There's also nice digital or electronic psychrometric charts anymore. You don't even have to break out the old psychrometric chart and get your ruler out there. They have digital psychrometric charts now where you can just pinpoint your locations to determine a desired wet ball or dry ball temperature, given you're entering air conditions or mixed conditions. So that's a handy little tool that they offer as well. If we look at some of the other applications, if we say some of the other design or selection methods, we mentioned, natural ventilation method or mechanical ventilation method. So let's say you're trying to help a customer size the humidification for that same building. You don't know the dimensions. All you know is you have the information on the makeup air unit or the air handler for that building, and you know that we can approximate a design condition. We can actually come up with a rough estimate on the load. So let's say you know it's a 10,000 CFM makeup air unit with about 20% outside air, maybe an 80-20. And then we know we want probably around 70 degrees with a 50% relative humidity. Well, if we just have that information, right, we've got our design temperatures and our space design. We just enter in that 10,000 CFM with 20% outside air. It can also give us an approximation on the humidity requirement. And as you can see, they're almost identical, 65 and 67 pounds per hour, so they're really close. So with just minimal information, some of these software programs have allowed us to get a really good rule of thumb or a really good selection on how much humidity is required. Obviously, if there's any other components to that space, whether it be process or heavy economizer usage, we want to incorporate the economizer airflow and know what our true mixed air conditions are going to be in that space. But to just get a rough estimate, it's really great to be able to jump online and just work with some of these softwares. From that software, what's really nice is that it will take you directly. If I'm in this software, it'll take me directly to the next screen, which actually shows me 4 different options of humidifiers that are covered in that range. So that 65 to 67 pounds per hour, it gives me 4 different options for a steam humidification system. Or we can look at the adiabatic humidification system. So it helps to narrow down by capacity. So then from here you can choose based on the voltage that you need or the water quality type that you're working with, which of these systems would be ideal for you. So we can work with you as well on that. So it helps try to help you narrow down all these selections into something that's perfect for your application. Specialty applications are always, we're always here to design and help support with the factory. So feel free to give us a call, or always include Doug Love, and he can help as our design expert for special applications. The nice thing is that once you've gone through and selected one of these specific systems, let's say, we have tap water, great, I can use, the Humisteam system, the Electrode system. We go in and we can select that Electrode system. And what's nice is that depending on the ductwork size, which determines whether you want, the size of your distribution tubes, it can automatically give you every single component that you need to complete that system. So these systems are sold as packages altogether. And as you see down here, it also includes a spare cylinder, so your first replacement cylinder. And it's nice for you as far as offering packages, service and maintenance packages for your customer for their humidifiers. Not only the annual cleaning, but the annual cylinder change out as well. So that's different opportunities for you as well as a contractor. All those different types of humidifiers obviously have different applications, but some of the things that you may not pinpoint, or people that may have issues with humidity that don't know it, are some of these specific applications. Printing presses. There's a lot of printers in the area that you have to have that perfect humidity, relative humidity in the space so the paper doesn't stick, it doesn't crinkle, it doesn't curl. So these are things that you can offer customers. They may have those issues. They may not realize they have those issues. But the wine industry, wine storage, wine transportation, all have to be regulated on relative humidity. Obviously, we know woodworking. Wood is severely affected by the relative humidity and the sensible energy in its space. Clean rooms and static control. These are huge. Static discharge is a huge issue, obviously, with circuitry, circuit boards, electronics in the manufacturing process of these systems. So they have to be tightly controlled. Obviously, textiles, and we talked about preservation earlier as well with museums and libraries, and then comfort in offices, schools, and hospitals. So there's a lot of different applications where you can offer your customer a humidification solution where they didn't actually realize there's options out there. They may be relying on the 80-20 system to modulate as soon as that economizer comes on, everything goes out the window, their design goes out the window. So you can still use a humidification system to tightly control the relative humidity in a space, depending on the season and depending on the load. So there are a lot of things that you can identify and offer to your customer that may be a little bit different. These commercial systems are a lot more precise than residential. Now, the website that we were just on was www.humidifynow.com. That's one of the free software links that you can use to actually download the software, use the electronic psychrometric chart, and access the selection software just to get a better idea of what type of sizing and systems that you can see. So there's different things that you can do, and also you can go to www.carelusa.com, and you can actually go online and see the different products and see the different applications as well. So there's a lot of options for getting online, and they make it easy for you to jump on yourself and just do a quick selection and sizing for the system. So that's a quick overview of just the humidification products that are offered in the commercial type systems. As you know, go ahead and email me any questions. Doug was not able to get on, I think, phone conference-wise, but we can always get him involved for any specialty design applications. We do, obviously, webinar trainings every Monday at noon. I think the next one coming up here is, system sensor, so smoke detector systems and other code-required rooftop equipment is going to be next Monday on July 16th. But any other questions or anything that you have, feel free to email me, and I'll leave that website up so you can see that, and I'll stay online here so I can answer a few questions as well if you have any on commercial systems or have a job that you need some sizing on. Thanks for joining us today.